Hey everybody, today we're going to learn about direct and inverse variation, and a little extra at the very end, we'll do a little joint variation as well. So here we go. Okay, let me shrink this so I can read it. Okay, it says, direct variation, as we saw earlier this year, is when you have the equation y equaling a times x, and again our a is our what we call the constant of variation. Okay. Now, a way to tell you might be dealing with direct variation is as your x values are going up, your y values are also increasing. And you're going to be multiplying by the same amount each time. That's where the constant of variation comes in, because that's what you're going to be multiplying by every single time. Okay? So. Alright, so let's take a look. The variables x and y vary directly. Write the equation that relates x and y, and then find y when x is 12. All right, so again, we're going to start with our basic substitution. We have our formula y equaling ax, right? You know that x is 4 and y is 8. So we're just going to substitute. So that's simple. 8 equals a times 4. Okay. So now I'm going to solve the equation, divide by 4. So 2 is equal to a. But we're not done yet, as one of my students is so fond of saying, but wait, there's more. So we're going to put this 2 back in for a and reset. So y equals 2x. So that's our equation. That's our direct variation equation. Now part 2 of this question then said, I want you to put 12 in for x and solve for y. So that's simple. Y is equal to 2x, right? So y is equal to 2 times 12. So y is 24. Pretty simple stuff. Okay. So let's split that a little bit here. There we go. All right. So let's look at the next one. So we start with our function y equaling ax. Okay. So I'm going to substitute negative 3 for x and negative 5 for y. Negative 5 equals a times negative 3.
Determine whether the trial data supports
divide by negative 3.
Okay, your goal is to
So
determine
evaluate
what type of liquid
5
affects the density
thirds
of the liquids.
equals
Now, do you remember how
a.
the liquids react to each other?
Okay.
What happened?
So we reset. Y
So you don't
equals
understand.
5
Okay.
thirds
So what is
x.
density?
All right. So now let's go back.
It is the thickness of something. Or
So
something
y
that is
equals
heavier than something
5
else.
thirds
So
times 12.
what was heavier in that water?
Okay. Now we use our check trick.
You drop a
12
bowling
times
ball
5
in
is
the wa-
60. Divide
in
by
a
3 is
pool.
20.
What does it do?
And there it
You
goes.
drop a bowling ball
All right.
into a pool. What does it
All right.
do?
Let's go to the next one.
No. One interesting
All right. So another thing we're going to have to worry about is the end result. How to tell if an equation is a direct variation equation. Remember, the end result should be y equals ax. So we have to solve for y and see if we have this ending format or not. So for this first one, if I'm solving for y, I start by adding the 5x. X. So 2y equals 5x plus 0 if you want to have the plus 0, but it's not needed. Divide everything by 2. Y equals 5 halves of x. So the question is, does this look like this? And the answer is yes. Yeah, my a value is still a fraction, but that's okay. So we know that this is indeed direct variation. Okay? Now looking at this next one. Okay, so what I'm going to do, again, solve for y. So divide by 5. Y equals negative 4/5 x.
Yes, I pressed the
So again, does this look like this? The answer is yes. So this again also direct variation. Now when I look at this one, I'm going to start by adding 4. So y equals 3x plus 4. Is this an example of direct variation? Does this look like this? And the answer is no, because of this. Because I have the plus 4, this is not direction variation. So this is a no. Okay? Alright, so that's what we're looking for here. To tell if it's direct variation, solve for y, and it has to look like the y equaling ax format. Now, when it comes to the word problems, one thing that we have to be very careful of when writing an equation is the difference between something saying relates to as a function or versus as a function of. When I hear, and again, you're given the instructions, write an equation that relates, say, d to t. Okay? When I see the word relates, that tells me that the first term I'm going to see is my x value, and the second term is going to be my y. So if I see, so let's say it relates,
You're not doing math, you're doing science.
relates d to t, and I tell you that d is equal to 6 and y is equal to 14, let's say. Or, I'm sorry, not y. Thinking of x and y, sorry. Let's say t is 14. And I say, okay, I want you to write the equation that relates d to t. Again, because d was listed first, that is my x. So d is really x. My t is really my y. So to write the equation that relates d to t, we would say 14 is equal to a times 6, using our direct variation formula. Now I divide by 6 and reduce, so 7/3 is going to equal to a. So my direct variation, y, would equal to 7/3 of x. And then, let me shrink that down a little bit so I have more room. Stop it.
You're lucky. I have to learn about density
Okay,
of water.
so now we should put this in proper form. So my y was t equals to 7/3, and my x was d. Okay, so this would be our equation if we were relating d to t. Now, write d as a function of t. Okay, now when I see some as a function of, this goes back to kind of our Algebra 1 stuff, where they've reversed this. The d now becomes my y, and the t becomes my x. Okay, so again, along the same format, okay, so let's say d is equal to 6, and did it again. Did it again. And my t is equal to, say, 14 again. Did it again. Did it again. So this time, my d is my y. So y equals 6. Yes, I did it again. And my t is technically my x this time. I did it again. So if I'm doing my direct variation, y equals ax,
Whoever took out the trash needs to put it back in.
that would be me, so somebody else could do that.
I'm working on something.
I'm in the middle of my math thing.
Times 6, divide by 6, so, oh wait a minute, I did this backwards.
My bot.
Sorry about that. Again, multiple distractions here. Okay, so this time my y is 6, and my x value is 14. So divide by 14s. This time 3/7 is equal to a. Gotta shrink this down some more. So to set my equation, y would equal to 3/7 of x. And make sure you use the proper variables. The y is d, so d would equal 3/7 of t. So again, be careful. If kind of a way to know, if you don't see this phrase right here, then you're obviously going to use this one. If you see right as a function of, then you're going to use this setup. So again, just be very, very careful with this. Okay, now let's talk about inverse variation. So y is equal to a divided by x. That's what this looks like, okay? Now, kind of a way to tell we're dealing with an inverse Okay, as my x values are going up, my y values are going down because of the fact that we are dividing by the same value or we are multiplying with a fraction. Okay. So, again, technically we're multiplying by a fraction. But again, see, the reason why the values are going to go down as the x's go up is because of this. The larger number I put in here, that means whatever a value, because remember, a is still our constant of variation, that number's not going to change. So if this is, say, 300 and you divide it by 2, that's 150, right? But the second I say, let's divide it by 5. Well, 300 divided by 5 is 60. You know, as the x values continue to increase, you know, your y values are going to decrease. Okay, so that's why this is going to do that. That's why it's called an inverse, because as the x's go up, the y's are going down. All right, so now let's take a look at inverse variation examples. Now again, we're asked to write, we're told that x and y are varying indirectly, or inversely I should say. Write an equation that relates x to y. So again, just like we did with direct variation, only this time our formula y is equal to a divided by x.
Corona. I got the corona.
Okay. So we're going to just substitute. Y is 3 is equal to a divided by 4. And we're going to solve for a. So we're going to times both sides by 4. So 12 is equal to a. But again, as one of my students is so fond of saying, but we're not done yet, we have to go back. We're going to put this back in for my a value here. So y is equal to 12 over x. So there's our inverse variation. Okay, so now for the second part of this, I kind of made this too big because I forgot there's a second part. So now at this point, now we're going to put 12 in for x again. So we're going to put 12 in for x and solve for y. So we're going to take our equation. Y is equal to 12 divided by 12. Therefore, y is 1. Okay. All right, so there's the first one.
What's over there?
All right, let's take a look at another one. Item number 2 says
Stuff. What's
x
there?
is equal to 8, y is 1. So we start with our formula. Y is equal to a divided by x.
Did you find it?
Okay. So we substitute. 8 is equal to a divided by -1. Okay, so now I'm going to clear the ugly fractions. I'm going to times by -1. So -8 is equal to a. Right, but remember, there's more. We got to put this back in here. So y now equals to -8 over x. So there's our inverse variation. So now at this point, let's put 12 in for x. Let me minimize this. Whoop, there we go. So let's put this on. Hey, stop it. Come back here. Hate it when I forget to deselect my pens. All right, so now let's put this. Hey, stop it. All right, so here we go. We're going to put 12 in for my x. So y is equal to -8 over 12, which just reduced the fraction. All I really can do here by 4, so you get -2/3. Okay, so that's pretty simple. All right, let's get ugly with the fractions. I know, it is almost Fun Fraction Friday, everybody, so we got to be ready for that. So y is equal to a over x. Okay, so now this time, my x is going to be 1/2, and my y is 12. So 12 is equal to a divided by 1/2. Okay, now again, as we know about complex fractions, okay, I am just going to make this a over 1. And remember, we're going to multiply by the common denominator of the denominators. Which means in English, if I'm looking at 1 and I'm looking at 2, what would my common denominator be? Well, it would be 2's. So I'm going to multiply this by a 2 and this guy down here by a 2. So 12 is equal to. Now,
Great.
2 over 1 doesn't reduce, so we're just going to multiply this together. So you're going to get 2a. But here, 2 times 1 is 2, divided by 2 completely cancels. So we're left with, that makes it just a 1, or just the 2a left. So now I'm going to solve, divide by 2, oops. divide by the 2. Therefore, 6 is equal to A. Okay. Okay, so A is 6. So let's put that back in and see what happens. So I'm going to put that back in for my A. So this goes all the way back up here. So y is equal to 6 over x. I got to shrink this down some more because of the fun fractions we had. All right, so now at this point, let's put in our 12 for x because that's what the problem said to do. So y equals 6 over 12, which is 1/2. Now, one of the common things I get with stuff like this is, gee, after I find my direct variation equation, which is this right here, this in this example, that one, and this right here. Once I find those variation problems, am I always going back and putting 12 in for x? The answer is no. That all depends on the problem itself. So that's why you're going to have to read these things and make sure you know what you're filling in. They may say put 8 in for y. They could say put 2 in for x. So just be very, very cautious. Make sure you're reading the problem all the way through. Okay? All right, so let's continue on with this video. All right, so here you go. How to tell if an equation is an inverse variation. Again, just like direct variation, we are going to solve for the y, and your problem has to look like this. So y has to equal some number over x. If it doesn't look like that, you do not have inverse variation. Okay, so let's take a look at the first one. So I'm going to solve for y, but if I look at this really closely, and I'm just going to switch this thing around, y is equal to 3x. It's already solved for me, so I'm already done solving wise.
I have to wash my hands.
But now, does this look like this? The answer is no. This is a direct variation because it's y equals ax, but it's not inverse because it doesn't look like divided by x. So this is not inverse, this is direct. All right, let's take a look at number 2. Okay, so in this case, xy is equal to 0.75. We have a decimal, yay, no real big deal there. So first thing I'm going to do is I'm going to divide by x because I need y by itself. So y is equal to 0.75 divided by x. Now, looking at that, does this look like this? The answer is yes. I have a constant over x. So yes, this is an inverse variation. Okay. All right, now looking at my third option. Okay, I need to solve for y, so I'm going to minus the 5. Y is equal to x minus 5. Is this an example of inverse variation? The answer again is no. It's because of this minus here. We don't have any division, first of all, and we have this minus. So this is none. This is not inverse. This is not direct. This isn't really a variation at all based on what we know so far. So just be very careful. So our only winner on this one was the guy in the middle. Okay. All right. One of our little extra features is joint variation. Okay, where they're going to say z is equal to a times x times y. Okay. So again, what we're going to be doing, okay, is you're going to be basically told to create the function that does this. So we'll look at that in the next slide.
Give me your tongue, Bobo.
Okay. So here's our example. Okay. The variable z varies jointly. Okay, so again, we're told that the variable z varies jointly with x and y. So z is equal to a times x times y. So I have this. Okay. I'm told that z is negative 0.75. I'm told that x is 3 and y is negative 5. So that's going to help me solve and go get a. Write the equation that relates x, y, and z. So that's basically saying create the equation that does this. Okay. Then afterwards, they're going to say, okay, find z when they give us these parameters right here. Okay. So find z when x is 2 and y is 6. All right. So, but first we've got to get the equation. So we're going to do negative 0.75 is equal to a times 3 times negative 5. That looks terrible. Hold on, let me fix that. That looks better. All right, so now we're going to multiply all this together next. So negative 0.75 is equal to negative 15a. Okay. So now we're going to divide the we're going to divide by the negative 15. Okay. So calculator time. So we're going to do negative 0.75 divided by negative 15, and I get positive 0.05 is equal to a, which means my equation is z is equal to 0.05 xy. So here's your joint variation problem. Okay. Now they say, okay, now knowing this, so your equation z is equal to 0.05 xy, they want you to fill 2 in for x, 6 in for y, and solve this out. So z equals to 0.05 times x, which is 2, times y, which is 6. Okay. So I'm going to multiply all this mess together. Z is equal to, so 0.05, oh, let me clear my calculator here. So 0.05 times 2 times 6. And yes, I know I could have done that faster by multiplying by 12, but I didn't, so there. So Z is equal to 0.6. And that would be our answer. So again, if you're asked for just the equation, it would be this. And then evaluating. And like I said earlier, these values here, depending on your problem, may change. So make sure you're keeping up with what's going on in the problem. All right, so that's it for now. So hopefully you got a lot out of this. And again, I will see you in the next video. All right, have fun.